Today's lesson is the intermediate value theorem, and this is the first of what I'll call the existence theorems. This means that this is a theorem that you're not necessarily going to use to solve a math problem. You're not going to have an equation down. You're going to be like, let's intermediate value this thing, and I'll get an answer. No, this is a theorem that is used as kind of a basis, sort of like Euclid's axioms in geometry. This is a basic theorem that we use to help prove other theorems. Because every rule, every theorem is a proven rule that shows it works 100% of the time. So this existence theorem, put quite simply, is saying if you have a function that is continuous, and just to be specific, we're going to say, for the lawyers, it's continuous on the closed interval from A to B. A and B are different points. So if it's a continuous function, no matter what y value you pick out. So I got my a value and my b value here. They have corresponding y coordinate on the function. I can pick out any y coordinate I want in between those. There's got to be an x coordinate down here so that f of c equals w. Basically, it's saying if this is really continuous, it's going to hit every point between a and b. Every y value will be crossed at least once. Every x value will be crossed at least once because it's continuous. So I hope, theoretically, this makes a lot of sense. And could it cross a certain y coordinate more than once? Sure, maybe right here and right there, they're at the same height. You could cross it in any number of times, but if it's truly continuous, I can't skip any of the points between this and that, between those two endpoints. Here's what the official definition looks like, though. That's it. That's your definition right there. The function's continuous no matter what y value you pick out between our two boundaries. We have to pick a boundary at a and b. Any y value between those boundaries, there has to be a corresponding x value so that f of that x value equals the y value. It just means there's no gaps. There's no gaps in a continuous function. So that's a very simple concept, but where on earth would you possibly use this? Right here. You use the intermediate value theorem every time you try and find the zero of something. So you've got a function on your graphing calculator, and you're trying to find the zero, where it crosses the x-axis. That could be also called a root, a zero, an x-intercept. Gosh, there's one more. I'm forgetting what the name is right now, but essentially what you do on the graphing calculator is you go up to just above trace, go to calculate, you hit the 0 button, and then it gives you the ultimate question. What's the lower bound? Wait a second. As soon as you answer that, then it's going to ask you what's the upper bound. And here's what it's really saying. It basically wants you to pick out one point that's going to be above it, and it wants you to pick out one point that's going to be below it. And even though they use the words lower and upper bound, one lower to mean an x-coordinate farther to the left, and upper meaning an x-coordinate to the right. Well, what they're really doing is having you pick out one point that's above the x-axis and one that's below. That way, they know if this is a continuous function, there must be some point in between. The computer will not waste time looking for something unless it knows there's a zero in between. So it checks to see, is the function continuous between those points? And then where is it? Does the intermediate value actually find that point for you? No. It's an existence theorem. It tells you it exists. But it's a foundation for other theorems and rules that we use in math and calculus specifically. Here's an example. Explain why this function has a 0 in the interval from -1 to 4. So this would just be stating that, hey, I know there's a 0 in there somewhere. Here's what you can do. Basically 2 steps. 1, is this a continuous function? 2, figure out what the endpoints actually are. And if the 2 endpoints at -1 and +4 actually have values greater than and less than 0, we know 0 is in between here. There must be at least one answer here.